everyone. Today we are going to discuss a nice problem from TIFR 2020 complex number problem. Is the problem number 12, which says you're given a set that is z1, z2, z7, a set of complex numbers such that the modulus of each complex number is 1, that is they have unit modulus. Then assume that they form the vertices of a regular heptagon in the complex plane, and there is something has been provided here, that is that this w thing, that is w equals to summation z1 multiplied with zi zj, and where I has to be less than j. And then which of the following is true? Number one is w equals to 0, mod w equals to 7, mod w equal to root 7, 7, and 1. These are the following four options have been given. Now here we will try to address the problem. Okay, great. Now since it has been provided that they are forming an heptagon, we should start the problem like this. That is, simply we will draw the coordinates, and we will start drawing the z1 over here on the real axis or on the x-axis. Okay, in fact you can draw the z1 at anywhere on the plane, but for the sake of simplicity I'm just keeping it on the real axis. Now similarly we will draw z2, z3, z4, z5, z6 and z7. Okay, and make sure that they are equidistant from the center. Although in my picture it's not perfect, but you can assume that they are all equidistant from the center, and all of them have length 1. That is something like this. Now we will construct the heptagon, which may look something like this, although the picture is absolutely not perfect. It's a very rough picture I'm drawing. Okay, great. Now the thing is, the angle between any two consecutive complex numbers should be 2 pi by 7. This one is 2 pi by 7, this one is also 2 pi by 7, so on and so forth. For everyone it's the same. Okay. now let's focus on the this term, that is the w equals to summation over I less than j zi zj. Okay, so in simplified form we can write it like this: z1 z2 plus z2, something like z1 z3 plus dot 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 up to z1 z7, plus this is one set, plus okay, remember that I cannot take z2 z1 because in that case I is getting bigger than j. That is not allowed as per that. Now the second set will be z2 z3 plus z2 z4 plus dot 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 up to z2 z7. Now with the same reason, it's z3 z4 dot 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 up to z3 z7, and eventually we will only end up with z6 z7. We cannot take anything further because after that z7 z1 will be there, and we cannot take that because with the same reason that I will be bigger than j. Okay, great. Now we will now to approach further, we will focus on to know that what happens if we multiply two complex numbers, that is suppose z and with suppose x and y. Suppose both belong to complex numbers and both have the same modulus. It not necessary to be 1, but I'm just writing 1 here because it's just 1. So as we know that this, in that case, this x can be written as some kind of e to the power I theta. Okay, because I have to see that what angle this theta is making with the real axis. Similarly, y will be something like e to the power I phi. Phi can be a different angle. Now what will we get from xy? That is basically e to the power I theta plus phi. Okay, so suppose if our x was somewhere here making an angle theta, this is our x complex number, and y has the same magnitude and it's making some angle phi. So our x multiplied with phi would be somewhere here with the same magnitude, but the angle will be the sum of the two angles. Okay, so this is how our xy would look like. They will just shift rotationally. Okay, so I will be using the same analogy here to figure out this problem. So observe that z1 is just 1. So if we multiply z2, that is the first one, it will give me simply z1. So okay, I'm doing one thing. I'm writing it as this first term of the w as k1, the second one as k2, third one as k3, and so on. The last one, since there are 6 terms, this is k6. You can write anything you want. For sake of simplicity, I'm just writing it over here just to explain. Now what will be our k1? In the k1, our first term is z2 plus the second term, that is z1 multiplied with z3, that is z1 so everything is going to be just the number itself, z3 plus z4 plus z5 plus dot 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 z7. Okay, great. So observe that this term is nothing but minus z1, because if we sum all the complex numbers, that is say z1 plus z2 plus z3 plus z7, it will give us 0. And if I just take this one on the other side, it will we will get z2 plus z3 plus dot 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 z7 equals to simply minus z1. So this is what our desired result is. I'm just putting it over here and making it z1. Now it's time to figure out our k2. What will be our k2? So k2 in the first term is z2 versus z3. So z2 is here, making an angle 2 pi plus 7. I'm sorry, 2 pi by 7. z3 is 2 pi by 7 again. It is making an angle of 4 pi by 7. I'm sorry. Yes, it's just making a 4 pi by 7 with the x-axis. So so even though we don't consider it as 2 pi by 7, I'm just simply putting it something like alpha. This is as alpha. Sorry, make it a little bit. Let it be alpha. This angle will be 2 alpha. This angle will be 3 alpha. This guy will be 4 alpha, and so on. So the entire angle will be 7 alpha. I'm sorry, I guess I made it a mistake. It should be yes, 7 alpha, because every angle is alpha itself, so we are just summing up the alphas, and the total angles are just the sum of the alphas. Okay, now k2, the first term is z2 plus z3. So z2 is making an angle alpha with the x-axis, and z3 is making an angle of 2 alpha with the x-axis. So z1 multiplied with z3, and I'm sorry, z2 multiplied with z3 will have something like e to the power I 3 alpha. So what is e to the power I 3 alpha? That is the z4, which is z4. So the first term will be z4 plus okay, I'm just erasing this part because I guess you have understood this and it's no longer in use. I mean, it's irrelevant to write it over here. I'm just writing down the necessary forms like z3, z4. So z2 is, I'm sorry, z2, z4. z2 is e to the power I alpha multiplied with e to the power I 3 alpha, which is e to the power I 4 alpha. That gives us e to the power I 4 alpha, means this our z5. So z4 plus z5 plus similarly so on. So on z5, z6, z7 and z1. So observe that here we are starting with 2, then 3, then 4, then 5, then 7. Okay, and here we started from z4, z5, then z5, then z6, the z7. After that we are returning back to z1, which means this summation is like the previously we figured out. It's nothing but minus z2 plus z3. Now it's time to, so our k2 is figured out, and we still have to figure out the k3, k4, k5 and k6. So k3 equals to z3 multiplied with z4. z3 multiplied with z4 means e to the power I2 alpha multiplied with e to the power I3 alpha, which means e to the power I5 alpha, which means our z6. So z6, similarly z3 z5 will be to your I2 alpha multiplied with I4 alpha. That means e to the power I6 alpha, which is z6. Then we have I'm sorry, it's z7 plus, again the z1 will come up. Now similarly z3 z7 will be to the power I2 alpha multiplied with e to the power I6 alpha 6 alpha, which is e to the power I8 alpha actually. So there is no 8 alpha. 8 alpha means simply the z2. Okay. So observe that in every step there is one term is missing. I mean, there are, if you look at K1, it says 1 2 3 4 5 6 terms, and it has 1 2 3 4 5 terms, and it has 1 2 3 4 terms. So and lesser the term, the higher the terms in the right side. So here also you will get minus z3 plus z4 plus z5. Again with K4 starts with z4 z5, which is e to the power I3 alpha multiplied with e to the power I4 alpha, that is e to the power I7 alpha. That is simply 1. Then with the previous analogy you can do it by yourself, but it would be z2 plus z3, which is nothing but minus z4 plus z5 plus z6 plus z7. Now it's time to figure out this K5. K5 means z5 z6, that is that is e to the power I4 alpha multiplied with e to the power I5 alpha, which is e to the power I9 alpha, which is nothing but e to the power I2 alpha, which is z3 plus the second term, that is z6 z7, will be, I'm sorry, z5 z7 power I to the right 10 alpha, which is nothing but e to the power I 3 alpha, which is z4. So this gives us minus z1 plus z2 plus z5 plus z6 plus z7. Now k6, which is z6 z7, which is e to the power I 5 alpha multiplied with e to the power I 6 alpha, which is e to the power 11 alpha, sorry, I 11 alpha, which is e to the power I 4 alpha, which is nothing but z5. So that is z5. Okay. z5 means, okay, let's z5 be z5 only. Now we will sum all of this k1, k2, k and k6. So w is basically equals to k1 plus k2 plus k3 plus dot 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 up to k6. Now k1 was minus z1, k2 is minus z2 plus z3, k4 is k3 is minus z3 z4 plus z5, k4 is minus z4 plus z5 plus z6 plus z7. k5 means minus c1 plus z2 plus z5 plus z6 plus z7. Okay, let's write k6 also, and k6 means minus z1 z2 z3 z7. Okay, I'm sorry, not z5, not z5. Six minus z7. Okay, now observe that each and every term like z1, z2 and z3, and everyone has the negative sign in front of them, and they are appearing exactly thrice in this whole expression. I mean, from here to here. So it becomes minus 3 z1 plus z2 plus z3 dot 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 z7. If you want, you can pause the video and review that. I just want to show you, that is, for example, for z1 we have 1 here. Okay, just a moment. Okay, one z1 we have here, the other one we have here, and the third one we have here. And next, the z2 we have one we have here, one we have here, and one we have here. Third, z3 one we have here, one we have here, and one we have here. Third, z4 fourth, the z4, one we have here, one we have here, and one we have here. Next, z5 one we have here, one we have here, one we have here, and so yeah, there are 3. Next, z6, one we have here, one we have here, and one we have here, and everyone has the same sign. So maybe here I'm just using the brackets, and here I'm just putting everything all together inside the parentheses or the brackets. But everyone in every term in this expression from here to here, every term containing a minus sign in front of them. And similarly, in the last but not the least, you can check that this z7 also arriving exactly thrice, one here, and one here. So the entire expression is going to be minus 3 z1 plus z2 plus z3 plus z4 plus z7 z5 z6 z7. Okay, now as I discussed earlier, that this entire term is 0, so it's basically 0, because we already know that z1 z2 z7 is going to give us a 0 resultant. Hence our w we are getting from here, we are getting our w is equals to 0. Now this is what the first option says, that w1 option A, w is equals to 0 is the answer. And I think that's a good place to stop.